Students, this is question 11. Let me write the question down. The equation of a curve is such that dy over dx is given to be as 6x squared negative 30x positive 6a. A is a positive constant and the curve has a stationary point at a comma negative 15. Now the first question is find the value of a. So that's the first one. The next one is determine the nature of the stationary point. Next is find the equation of the curve, and the last one is find other stationary points. Okay, so this is a simple representation of the question. Now foremost, what is given is that, so let me write the solution. Given, what is given? Dy over dx is equal to 6x squared negative 30x positive 6a. Now since it is given, since we are given the curve as a stationary point, this means dy over dx is equal to 0. So this in turn means 6x squared negative 30x positive 6a is equal to 0. Okay. Now we are given that the curve has a stationary point at a comma negative 15. So that means x is equal to a. So at a comma negative 15 we have, so x takes the value a, so 6a squared negative 30a positive 6a is equal to 0. You add these two together, you get negative 24a is equal to 0. You take 6a out, you get a minus 4 equal to 0. Now 6a cannot be equal to 0, so a negative 4 is equal to 0. This means a is equal to 4. So you got the value of a. So first part is done. Now we are asked to determine the nature. Okay, to find the nature of the stationary point, consider dy over dx is equal to 6x squared negative 30x positive 6a. So at a is equal to 4, dy over dx is 6x squared negative 30x positive 24. Now we differentiate this with respect to x, we get, so what do we get? So let me move to the next page and write dy over dx. So dy over dx is got, and so 6x squared negative 30x plus 24. Yes, that's plus 24. So as I mentioned to you, we are differentiating this with respect to x, and this would give us d squared y over dx squared is equal to 12x negative 30. Now at x is equal to 4, because that's the point that has been given, so we need to get that value. So it's 12 times of 4 negative 30, which means 48 negative 30, which means 18, which is greater than 0. So this means the point is actually a minimum. So this means the stationary point obtained is a minimum, right? So that completes the second part of the question. So now we are asked to get the equation of the curve. So that's the third part. We have to find the equation of the curve. So how do we do that? For that, consider dy over dx is equal to 6x squared negative 30x positive 24. Now you cross multiply, you get dy is equal to 6x squared negative 30x positive 24 times the dx. Integrating, we get, so what do you get? You get integral dy is equal to integral 6x squared negative 30x positive 24 times the dx. You distribute this, so 6 times x squared dx negative 30 times x dx positive 24 times the dx. Integrate this, you get 6 times x to the power of 3 divided by 3 negative 30x squared over 2 positive 24x positive c. Over here you get y. Now we have to use, so let me move on to the using 4 comma negative 15 in say 3. I'm going to take this as 3. Okay, so we get, so what do we get? We get, so this point is negative, y is negative 15, and we will substitute here. So before that, let me rewrite this as 2 times x to the power of 3 negative 15x squared positive 24x positive c. This is y. So negative 15 is equal to 2 times of 4 cubed negative 15 times 4 squared 24 times of 4 positive c. So 4 was a 16 times of 4 is 64. So 2 times of 64, 15 times of 16 positive, 4 4s are 16, 1 4 is 8, 9 positive c. You have negative 15 here. So now you will have to calculate. So let me add it up. So this is going to give me 128 and 15 into 16, 33, 9, 5, 1, 0, 14 and 2, 240, minus 240 plus 96. So 128 and 96, this is going to be 14, 110, 12, 1, 224. So from 224, I subtract 240. So this is going to give me 10, 6, some 3 you take away 2, you get 16. So this is negative 16. Of course, there is a positive c there, and you have negative 15. So I move this to the other side, I get negative 15 positive 16 is equal to c. So therefore, we are getting the value of c is equal to 1. So that means the equation of the curve is, so you take the value of c and you substitute here. Equation of the curve here is y is equal to 2 times x to the power of 3 negative 15x squared 24x positive 1. Okay, you can box this result. Okay, now that is done. So now what we have to do is we will have to find the other stationary point. Okay, so for that, let's do that final part. We have dy over dx 6x squared negative 30x positive 24. So to get the other stationary point, let me write that. To get the other stationary point, set dy over dx is equal to 0. So this means 6x squared negative 30x positive 24 is equal to 0. You divide by 6, you get x squared negative 5x positive 4 is equal to 0. You factorize this, you get x negative 4 and x negative 1 is equal to 0. X is equal to 4 is already obtained, and x is equal to 1 would be the other point. Now so we need to get the coordinate, right? So at x is equal to 1, okay, we have, so what do we have? You take x is equal to 1 and you substitute it in say 4. So that is going to be y is equal to 2 times of 1 raised to the power of 3 negative 15 times of 1 raised to the power of 2 positive 24 of 1 positive 1. So this will give you 2 negative 15 positive 24 positive 1, and you add these two together, that is going to give you 9. This would be 3. So 3 added with 9 would give you 12. So therefore y is equal to 12. Okay. So hence the coordinate, therefore the coordinate of the other stationary point, so I'm just giving a short form here, coordinate of the other stationary point is 1 comma 12. Okay, so we have got all of the required subdivisions for this question, and that completes this paper, students. Until we meet again, thank you.